Hello guys, good morning. Welcome to another episode of Xa Talk Show. We are going to code Wolfram language. I'm going to give you a ground up tutorial on how to program graphics in Wolfram language, such as this one you are seeing. This is called pedal curve. So graphics for beginners, Wolfram language, okay? If you are here, say hi. Love to see your comments. Keep them coming. If you are watching this offline, play at 1.5 speed and skip around because I ramble. Okay, let's start Wolfram language. Video check, audio check. Good. So say hi for people watching. So we started Wolfram language. So let me prepare a little bit. Let's put this here, and the size is good. So we're gonna code negative pedal. Okay, let me explain. So go to today's talk show, show in browser, Xa Talk Show today. Okay, so we're gonna code this. So let me show you. First of all, I have the code already, but I'm gonna do it from scratch. Okay, so let me show you the code. So let's copy it. Copy. Go here, showing browser. Okay, that's today, and let's start a Wolfram language. Paste the code here, pop it out. So that's a Wolfram language code. And if you don't know already, look at my Wolfram language tutorial. Just search for Xa Wolfram language tutorial. You'll find comprehensive tutorial on graphics and everything, and also where to download. It's free since about 3 or 4 years ago. You can download, and and you need to install Jupyter so that you get graphics for the free download. Otherwise, you just buy Wolfram language. Okay, then you get the notebook. So so you got the tutorial, and then you got my Wolfram language tutorial, my packages for Wolfram language for plane curves. That's very relevant for what we are doing today. So this is written like 30 years ago, and I updated last year. So I did a live stream updating it, and so it can draw all this. So what we are going to do today is to show you how do you actually program this. So for example, this is parabola, optical properties. And you can, so all you have to say is the formula, and say a length, and say the light source position, and it can draw all these rays. So that's the so you can draw many things: kissing, osculating circle, evolute, involute, all sort of things. So we're gonna show you how to do that, how to program these. Okay, and in particular, there's one pedal curve. So this is what we are doing related today, pedal. So then there is, so go back, then there is Xa Wolfram mod, which is allows me to code Wolfram language in Emacs. So I'm using Xafly keys, and I'm using Wolfram keyboard. Okay, so let's begin. So unit V, so we actually updated the code a few days ago. Let's see, Xa Talk Show, Wolfram language, F#, Emacs Lisp, pedal curve. So this is March 23rd. We did this, and we got the code updated here. So let's begin from this. Okay, copy, select or paste. So let me just show you first of all what does this thing do. Okay, copy. And then, okay, so let's see. So I don't want that. Close. New Wolfram notebook. Paste it there. Okay, and magnify. Let's say 125. Okay, then here is the code. Control Shift D to split them into two different cells. Okay, so evaluate this code. Shift Enter. That's done. Then you can just type this and it'll plot it. So first of all, Control Shift N to make it typeset. You can see beautiful typesetting. So then Shift Enter. Fantastic. So that's what we're gonna do. I'm gonna explain the code, okay? So you can see now we can change the point here. So let's say 1 and 1. So at the x equals 1, y equals 1, shift enter, then you got a different graphics skewed. And you can do an animation. So let's say, for example, yeah, for fun, let's do an animation. Let's see. Okay, manipulate then this expression, and then let's see, how do you type the correct, yeah, so manipulate from, let's say, t from 0 to 1. Okay, now I don't remember that's so manipulate take two arguments. First one is the expression, the second one is a variable, a range, and a range. So now let's change it to, so x is 1, let's move y from 0 to 1, so this would be t. Now I don't know if this is correct syntax, but let's try it first. Fantastic, you can see. So now you got the slider. Okay, let's magnify more. You got the slider and you can move it. Fantastic. Can you see that? So this is the point moving up. You see that blue dot over there? You see? So this curve, I mean these lines forms a curve. So the red dots is a parabola, okay? Basically y equals to x squared. And then the black lines, they form a curve. This is called the envelope of the lines. So this new curve is called the negative pedal of the parabola with respect to this blue point. Okay, so that. Okay, so that is kind of the demo of this code. So the code is just this part. This part, okay. Above that is the documentation, the inline documentation for that. Okay, let's begin with, so we're gonna write this code. Let's see, where do we begin? Let me just begin to tell you how do you do graphics. Blue Owl, hi, always love mathematics, math contents, fascinating, yeah. So we're gonna show you how to generate graphics, okay? So let me just begin to show you, okay? So let's put it back. Let's create a new Wolfram language. Pop it out. Okay. So Wolfram language, when you want to draw a line or a circle, they are represented by what's called graphics primitives. So for example, let's type it here. So because Emax is so circle at 0.0 and radius 1. Okay, so if you evaluate that, shift enter, that represents the circle at this center and that radius. Okay, and to represent the line, all you have to do is just say line, and then a list of points. Let's say 0 to 1. Okay, so if you evaluate it, it returns itself. When it doesn't do anything special, but it just represents the line or circle. Okay. Now, if you want to, so these are called graphics primitives. So you have circle, you have line, you have points, you have rectangle, and also there are 3D ones such as tube, a polygon, and things like that. Also, polygon can represent a 2D graphics. Let's say polygon. Let's just do some. Okay. So polygon. And we want polygon is a list of points. Let's say 0, 0, 0, 1, and let's say 2 and 3. Okay, just some random numbers. Okay, so shift enter. So it tells you this is a number of points 3 embedding dimension 2. So this is a polygon in 2 dimension. This output is kind of makes it easier to see, because usually when you have a polygon, you have thousands of thousands of points. Especially in 3D. In 3D, then you anyway. So let me continue. Okay, so these are called graphics primitives. Okay, so now you can also check out my Wolfram language tutorial, and then you go down, there's a section on graphics which will cover all the things we talks about graphics programming. Okay, so there are many topics. So first of all is how to plot. This is simple. You don't have to program anything. You can plot surfaces, pie chart, and so on. Okay, and then parametric 3D surfaces. Then here is about related to programming. So you got graphics primitives, you got points, you got line, you got polygon, we covered. Then you got text, disk, circle, rectangle. Then you have 3D, three-dimensional graphics primitives, points, line, polygon, sphere, cuboid, tube. Okay, so by themselves, they don't do anything. But if you want to show it as a graphics, what you do is you say, not graphics 2D. Okay, so graph, graph graphics. Okay, so if you want to actually show them, then you say graphics. So for example, graphics circle 1. You see, now you got the graphics. Now if you want to show axis, then you have to say options. Let's say axis true, shift enter. So you see, so this is great. So if you want to show all these, for example, then you put them in a list. Okay, so give a list, all that, and remove that. Copy, paste, run. I got an error, so yeah, okay, you forgot the comma to separate them. Copy, paste, run. You see, we got a circle, we got a line. Let's show axis. Axis true, shift enter. So you see, now this polygon, the line and polygon, they overlap. So let's change the line to let's say 2, 1. Okay, copy, paste, run. So you see, you got a circle, you got a line, and you got the kind of a triangle. Let's say x is true, okay. So that's fundamentals. So this is very powerful. This is basically almost all you need to know about programming graphics in Wolfram language. Okay, so all you have to do, where is my talk show page? Hold on a second. Show talk show. You see, all you have to do to draw any of these fancy graphics, you see, they are just lines and points, is to create, just create this circle and, the position, and that's it. That's all you have to do. Very fundamental, just remember that. Now, if you want color, let's do it again. So if you want to have color, let me explain. To show the graphics primitives, use this graphics function, okay. Let's say put them inside the graphics. Okay, that's how you show. Okay, next, what about color? Color, thickness are called graphics directives. Okay, so all we have to do is very simple. All you have to do is, let's say you want the circle to be red, so you put inside the list again, and let's just say red. Okay, so now you'll get a red circle. Shift enter. Fantastic. And if you want the line to be blue, so you have to say put inside the list, then in the beginning just say blue. Okay, so you got a few, just like CSS, some colors are named, so you can say blue, but you can also say, for example, blue. Let's just show it. Okay, you got a blue line, and you can type them by itself. Let's say red. Run it. It returns a square representing red. You see, so blue is just blue. You see, you got like 10 names also: blue, red, white, cyan. But you want a general mechanism. You say hue. Okay, hue. Hue is like the rainbow modeling of the color. So hue 0 is red, then hue is brightness and saturation, something like that. Okay, let's say 1. Okay, that's red. Now let's say 0.5. So you got kind of brownish. So you can see the documentation for hue. It'll show you a table. So hue represents a color in HSB. So that's hue, saturation, brightness. That model, color model, has many different ones. You can also use RGB color if you want. Okay, in Wolfram language. So this shows the model of the using the HS, hue, saturation, brightness. Okay, that's about color. So you got, so we got the color, and similarly, okay, so not this one. So let's show the other one. Okay, so let's move this here, and let's put that one here. Okay, we got the color. And similarly for thickness, so let's say the polygon you want to be, if you don't want them to be closed, then you just use line instead. So, but for now, let's say I want them to be, okay, let's say thickness. Okay, thickness 0.1. Okay, so that is a percentage with respect to the graphics. Okay, so let's show it. You see, now you got the thick line. Okay, so that's the basic. That's almost like this is the fundamentals of the graphics. You got graphics primitives to represent the thing. Then you put them inside graphics that will show it. And if you want to control color, thickness, and so on, you use these so-called graphics directives. Okay, so now that's one thing. That's the basics of Wolfram language graphics here. Okay. So next, now we're gonna start to get fancy. We want to draw this thing. So what you have to do is that you want to draw. You see, the black lines is what we want to draw. So how do you get the black lines? You have to find, basically you need to find the position of each line. So line, remember, line is represented by just this, just this line, 2 points or a list of points. They'll draw it. So to draw this, all you have to do is you have to generate a list of lines, and you have to know their, like a vector, 2 positions. Okay. Now that part is mathematics. So to draw this one, you need to know, this is called negative pedal. So you need to know what is, like where are the points? How do you draw them? So that's defined. Negative pedal is this is a definition mathematically. Okay, so given a curve and a fixed point, O, draw a line from O to any point P on the curve. So given a curve, the red curve, and the fixed point O, such as the blue dot, then draw a line from O to any point P on the curve. So let's pick a point P. So let's say this one. Then draw a line perpendicular to line OP and passing P. So you want to draw a line passing P and perpendicular to the O to P. So that's gonna be this line. Can you see it? Okay. And then you just repeat this for every point on the curve. So for every dot on the parabola, this red dot, for every dot you draw a line, the black line. Okay, then you got these black lines. Okay, so that is the mathematical definition of negative pedal. The construction. Okay, the actual negative pedal means the curve that is formed by the envelope of these lines. So you got this kind of shape, teardrop shape. So mathematically, that the formed curve is called negative pedal, but the construction is by, drawing all these black lines. Okay. So that's what this code is doing. So all we have to do is, just say, the pedal point, and then you'll draw it. So the code is here. The code to do that is here. Okay. So now we're gonna explain that one. So that one. So far so good. So far so good, guys. Say something. So how long have I been? 30 minutes, half an hour. So now this is harder part. So let me see, how do I go about it? Yeah, so let's do this from scratch because it's easier to do from scratch. And then we want to let's do it from scratch. Let's write this function from scratch. Okay, so show in browser. Okay, this is existing code. Now let's do it from scratch. Okay, so let's put a new Wolfram language, paste. this is description of pedo. Okay, so program graphics program the negative pedo. Okay, so this part is a comment. This is what pedo means. So we gonna start simple. So given a curve parabola by the formula x squared, let's just say that, okay, for each point on the curve. And okay, so another thing, given a point, let's say 0, 1, okay, so x at 0, let's say y, let's say 1, 1, okay. This is called the pedo point, okay. Now we want to draw a line passing a point P on parabola, and we want to draw a line L passing point P on the parabola, given point O, okay. We want to draw a line passing point P on the parabola and is perpendicular. I don't have that shortcut, so let's create a shortcut. Let's digress and create a shortcut, perpendicular. So abbreviation. Perpendicular. Okay, I don't have that, so now I do. Evaluate the buffer, evaluate, close it. So perpendicular. Fantastic. Hand pen saver. So we want to draw a line L passing the point P on parabola and is perpendicular to the line OP. Okay, that's what we want to do. And we want to do this for many points P on the curve. Okay, so let's remove that. That's the thing we want to do. So first of all, so list of points. So first of all, we're gonna draw the red dots, a list of points for parabola. Okay, so what we do is we want the point primitive. We want to map. Okay, we want to map points to a bunch of list parabola. Okay, so let me just do it. So so what we want to do, parabola, yeah, parabola points equals to table x and x squared, and x from, let's say, -1 to 1 in steps of, let's say, 0.1. Okay, something. Okay, let's try it. Fantastic. These are the points on the parabola. Okay, now this table function is very powerful. It's similar to for example, Python's comprehension, list comprehension, idiotic term. Okay, so it's similar to list comprehension. It's a way to generate a list of or nested list. Okay, so hold on a second. Before anything, let's do wait. Let's do a screenshot of this so we have a record. Fantastic. And let's put it here. Show in browser. Today's talk show, go down. That's what we did. Fantastic. Now back to this programming this thing. Okay. So now parabola points, we got that, a list of points. Now all you have to do is you want each point to be not just a pair of numbers, you want to be with the point graphics primitive. Oh, I don't have it here, so but it's this one. Okay, so map that to the parabola list of points. That's it. So run it, show it. You see, you just add the point in front. Each one represents a graphics points. Okay, then what do you do? Graphics points, something like that. Okay, but let's just say dots. Dots equals to that. Okay. Okay, then you got a bunch of dots. Then what do you do? So let's evaluate it. That's what you have, dots. Okay. Then what's the next thing? Okay, so we can show graphics now. So graphics dots axis true. Fantastic, beautiful. Is that beautiful? Fantastic. We got a parabola. Now we want to make it red. So again, just say red. Okay. Paste. Fantastic and beautiful. Now, for each one of these points, you want the line, you want the pedal, you want the line that is perpendicular to another line. Okay, so how do you do that? That's so that would be linear algebra. You don't need linear algebra. You just need basic concept of vectors. This is what you learn in kind of pre-calculus. You don't even need calculus. You need to know the vectors. Vectors, move them around. How do you make it perpendicular to another vector? Things like that. Okay. And I have not done, I've done this like 30 years ago, so I don't actually remember. So, but we got a code, remember? So let's see. We got a code somewhere here we can grab. So looking at it, then I'll remember. So I'll show you, okay? We'll go this step by step. Okay, so next you want to draw, so this is what we want to draw. So first of all, draw points on parabola. That's what these do. Then next we want to draw a line L that is perpendicular to line OP. Okay, and O, remember, O is a given point. In our case, it's 1, 1. Okay, so let's say okay, so given a point, let's say pedal points, how do you name it? Given a point O, yeah, this is called pitot point. Okay, so let's define the point. Okay, so 1 1. It's we need this point. Pitot point equals to that. Okay. Draw a line that is perpendicular to line OP. So draw a line. Let's say this point. Okay, so given a point, let's say this point is some point on parabola. That would be, that would be one of these points. Let's say, is there a nice one? 0, 0. Okay, 0, 0 is a point on the parabola. So let's deal with this point first. Okay, we got a point there. Then we also got the pitot point, which is, which is the blue one. Okay, so we got 2 points. That's all we need. So next we need to draw a line that is, let's name this curve point. Okay, so we need to draw a line such that it passes the curve points and is perpendicular to pitot point to curve point. Okay, so this is line OP. So let's do this. Line OP. Okay, yeah, line OP. Line OP is very simple. It's just list of 2 points. Okay, one is curve points, pitot points. The other one is curve points. Okay, very simple. So this is line OP. Then now here is a line passing P and perpendicular to OP. Okay, how do you do that? Okay, so this is when you need basic vector. So you got a line, so this is a vector. You want to find another line, which is 2 points. You want to find another vector that is perpendicular to that. Okay, so let's look at the code. I forgot. Okay, this is basic vector geometry. Hi man, hi Pio. So well, so given a vector, you want to find another vector that is rotated 90 degrees. So all you have to do is you can kind of multiply by sine cosine. Okay, if I recall correctly. Let's see what I did here. Oh yeah, so yeah, okay, so I'm using a faster trick. All you have to do, okay, here's a trick. Given a vector AB, given a vector with components x equals to A, y equals to B, so AB, right? So like this. To find the perpendicular vector, a vector perpendicular to it, is you reverse it. So first of all, you make them negative, both component negative. Then you just reverse one of the sign. Okay, we can try it. Okay, so let's try. Okay, so okay, so let's say 0.11. Okay, so suppose you have a vector 1 1. you want to find the perpendicular vector rotated 90 degrees. So that would be, you see, that would be negative 1, 1, okay? So how do you do that for general, in general example? How do you, so what you do is you make them negative, you make both of, let's look at the code, okay? You make both of them negative, then you just reverse the sign of the second part, okay? So let's see if that works. So make both of them negative, then reverse the sign of the second part. So you got exactly, that works. So here's what to do, okay? So a line passing P and perpendicular to line OP. So to find a vector that is perpendicular to AB, to vector AB is negative A wait, oh, you just flipped, you just actually, all you have to do is just flip to the X component, is that right? Wait, what are we doing? Oh, and we have to reverse. Oh yeah, there's one part you forgot. You have to reverse. So the new one is actually BA. No, I don't feel. It's lousy question. Anyway, so I believe this is it. Okay, so let's say to find the vector that is perpendicular to vector AB, the result is negative BA. Okay, this is kind of a trick. You can work it out if you go, you go look up Wikipedia on vectors. Okay, but this is like a shortcut. So we can test it, okay? Graphics, let's just quickly test it. Let me show you. Wolfram and graphics, okay? So graphics line. So for example, clear. Let's say AABB, we clear two variables, okay? Then AA equals to let's say 2, okay? Then BB equals to, let's say 3, okay? So we have then vector x vector equals to AABB. So we got a vector. Now the per vec would be equals to negative BBAA. Okay, wait. That, okay, I believe, okay. So we can test this by just drawing the graphics, to see if we got it right. So line, so first of all, you draw two lines, okay. You draw two lines, that's one of them, and make it a list. So one of the first line is 0, 0 to wait, you need a list, okay. 0, 0 to x vector. So let's rename it vec1, vec2. Vec2 is perpendicular to vec1, suppose, okay? So vec1 is vec1, okay? 0, 0 to vec1, okay? And make it color red, okay? And the second one would be vec2 and make it blue, okay? So we got the code, beautiful. So this code will verify if our theory, this perpendicular vector, is correct. So we can go here, paste it, run it. Fantastic! Can you see that? Beautiful. So now if you change some variable, would it still work? You see, this is the beauty. So you can change this to, let's say, 2.5. Would that still work? Now remember, we want to show axis, because with axis that make it easier to see. Axis true, okay? Okay, 2, 3 becomes 3, negative 2. That's perpendicular, yes. Now let's say the vector, let's change. Let's say 2.5, shift enter. Would it still work? Yeah, seems so. Now let's say 9, make it big. Oh, it still works. Now let's say negative 9. Fantastic. We got orthogonal things. So our theory is correct. To find a vector that is perpendicular to vector AB, just swap them and make one component negative, okay? So it actually should be that. Okay, so along the way, we learned some vector geometry tricks. So now back to the thing we need to do. We got the curve points, we got pedal points. We need to draw a line passing the curve points and perpendicular to these two. Okay, so let's do it. So this is a new section. A line passing P and perpendicular to line OP. Okay, so we just need to create a P dot line. Neg P dot line equals to. So we got these two things. We swap them. Yeah. So this would be a line. These are the two coordinates. Right, so okay, so you have to, now you need to do no more vectors, because you need to translate them and normalize them and stuff. Okay, so yeah, okay, so the curve point, actually let's use a different curve point, because 0, 0 is kind of special. Yeah, so let's use a more generic curve point, something not 2 and 4, let's say. So you see, parabola points, let's say 2, 2, 2 in steps of 0.5. Okay, so these are some points on the parabola, and one of them is, you can see, 2, 4. Okay, so let's change this to 2, 4. It's a point on the curve. Okay, so now we draw the negative line. So what would it be? So it would be, let me show you. Okay, so this is a vector geometry, very basic. So you got curve points to pedal points to curve points. Okay, so and so let's so we talking. Okay, so which one is the vector? Yeah, so the vector is from the pedal point to curve points. Okay, pedal point to a point on the curve. Okay, so the vector would be pedal vector equals to curve points minus pedal point. Okay, that is the vector. Okay, then you want to, so that that line, that line segment, you want to normalize it. So you want to make it with length 1. So what you do is you just say normalize, not normal. Okay, so you just normalize this. Make them length 1. Okay, still in the same direction, but length 1. Okay, so you got that. Then you just so now that's a pedal vector. Now you just want to turn it 90 degrees so that it's perpendicular. So the new vector pedal line, this actually, let's name this vector OP. Okay, OP, yeah, vector OP. Okay, now the pedal line, vector pedal line would be, you swap them, so you say reverse. Okay, you swap the x and y, then you make the last one negative. So you have to do is time 1 negative 1. Okay, so equals to that. So that this line would be perpendicular to this. Okay, now am I doing good? Okay, so that, so we can actually try it. Yeah, so okay, we can try it. So now graphics. We want to draw vector OP. Line at least from 0, 0 to vector OP. Wait, we need to draw several things. Okay, so hold on a second. So first of all, let's draw the curve point. Okay, so there is a curve points, which is a point. Okay, now let's see, hold on a second, let's see, yeah, a point. So let's say blue. So we got a curve points, then, I mean, this is a pedal point. Wait, this what? Curve points, so first important thing is the pedal point. Okay, so let's copy that again. So the pedal point is colored blue. Okay, now the curve point is colored red, the point on the curve. Okay, got it, right? Then, okay, so you need a comma. Then, so we got the blue points, that, and we got the red point, that. Then we want to draw a line from the blue point to the red point, okay? So a line from pivotal point to curve points, okay? Let's say pink. Do we actually have that color? Yes. Show in browser. I mean, look up the documentation. Wolfram language documentation. Pink. There's a word to represent that color. Fantastic. Okay, so then next we want one more thing. We want this perpendicular to this, okay? But we can actually just show it first, so that reduce the mystery. Okay, so let me show it first, okay? Copy that, copy, go here, and let's paste it. Oh, we got error, so we got extra comma there. That's what we want to do. Paste, do it. Fantastic. We got a blue dot there. We got a red dot, supposedly a point on a curve. Then we got a pink line. That seems correct. Now remember to show axis. Okay, so let's show axis, okay? So that we can actually see. And let's change, I want the point size, okay? Point size, kind of make it bigger, 0.5, okay? Paste. Point size syntax is incorrect. It should be dot. Shift enter. Beautiful. Okay, now you see it automatically draw only the portion of the graph. So you see, so this point is a pivotal point, but we are not seeing the 0, 0. So let's put a plot range. Plot range -1 to 1. X-axis, y-axis. Let's say 3. So x is -3 to 3, y is -3 to 3. Okay. Do it again. Okay, we got some issue. We don't. There is no option called plot range. Okay, we need something else. I think. So what we have to. This option is not available. Okay, so, but it's available, I believe, in show. Okay, show takes 2 arguments. The first argument is the graphics. The second argument is whatever options. So let's move that to here. Okay, so the first, so x graphics equals to, so this is a graphics, then show that. Copy it, paste, do it. So we got one graphics, and the second one, list is not, yeah, so there's no such option. I forgot what is the option to limit the graphics to certain area. You can say it by options, add Let's see what is the option for aspect ratio, axis, axis label, axis origin, color output, display function, format type, frame label, image size, label style, plot range, clipping, plot range, all. Yes, there is a plot range. So plot range is an option of graphics. So why is that? Why is my use of plot range not why is my use of plot range not yeah, there is a plot range, right? 1 1 to 1 3 times 3. So why is my plot range not? Let's try it. List is not a type of graphics. Why is that? List is not a type of graphics. So that's graphics. X is true. What's going on with the plot range? Let's see. Documentation. Plot range is an option for graphics function that specifies what range of coordinates to include in the plot. Okay, so plot range automatic. Yeah. Let's see, plot region. So plot region, background sphere, graphics, plot region. Yeah, I want to get I want to find out what's wrong here. This is a minor issue. We shouldn't worry about it, but I do want to show, specify the range, and because that way we can see where our points are with respect to the 0 coordinate. So this is already 1 hour, I think. Okay, we almost done. So why is the plot range? Plot range list is not a type of graphics. What? I believe so. Plot range, or so that's part of the option of plot range. So graphics, yeah. So that, you see, why is that not working? So let's try again. Here, close that. Here, paste. Let's see, what does this? Oh, we got the syntax wrong. Why is this? Did I spell it wrong? Plot range. Yes, we spelled correctly. List is not a type of graphics. Oh, right. The plot range is not a function. It should be the arrow. That's so silly. Silly me. Okay, my mistake. Should be like that. an arrow. Okay, so now we got it. So now let's do it again. Let's do the whole thing. Wasted 5 minutes. There it is. So you can see, we can see the with respect to the the whole graphs. Now let's increase this to 5. Increase plot range. Shift enter. You can see the blue is the pedal point, the red is a point on a curve, and we draw a line. Now we want to draw a line perpendicular to this line and passing the red point. Okay, we almost done. One more step. Okay, so now one extra line. So that line would be, let's say, what color? Let's say black. Okay, so that line would be a line passing. Okay, so that line would be vector pedal line. Okay, so that line would be vector pedal line plus we are doing vector arithmetics. Vector pedal line times, let's say 10. Wait, not yet. So vector pedal line, you want to translate to the P. Okay, so translate to P. So P is curve point. Okay, then you want to increase the length. Okay, then you just, so that times 9. Okay, they will increase that. I think that's it. Do it. Okay, so something is wrong. Oh, we forgot the comma. No. Wait, did we? Oh, line. So line needs 2 points, right? So yeah, so this needs to be we got so vector pedal line, which is a vector, then plus curve points, you move it, then you magnify, then you need the curve points wait, so don't magnify that yet. So vector pedal line plus curve points so it would be curve points. Yeah, so wait, so this line would be starting with the curve points 2, what's the other point? To that times 9. Okay. Okay, let's try it. I hope this will do it. Okay, we're missing, it's not showing up. So plot range, let's increase the plot range. Okay, so yeah, God, we need to. Let's increase the plot range, okay? And let's make it easier now. Let's see. There it is, but it's incorrect. Our black line is incorrect. Wait, so did we reverse their yeah, we didn't reverse. Wait, we did. So vector pedo line. Oh yeah, so wait. So vector, so that should work. Vector pedo line. And it's not, it's, there it is. We multiplied wrong. So if you want to multiply, I mean, so anyway, that is, we this is one step to draw all these black lines. We kind of did it. Now we just need to increase the length of the black line. So let's do that, and that'll be it. So we need to increase the length of black line. So let's this line, let's make, so there is another primitive, graphics primitive in Wolfram language that represent lines infinite, not just a segment, but going in both directions. So let's look at the entire list of graphics primitives. So you got disk, circle, rectangle, raster. You got, okay, line, polygon. Now let's magnify. Okay, you got line, polygon. You got, let's click line. No, not that. Let's see 2D graphics object. There it is. So you got points, point size, line, half line, infinite line. That's what we want. So just change this to infinite line. Okay, so copy back to Wolfram language, paste. Beautiful. Okay, that's it for today. Thank you guys for watching. Now we reduced to 4 people. Okay, so hello Saifu. Thanks for setting my slot up. What? Please set Skater 3 Gator. What? Okay, that's it. Thank you guys. So here is a code. Fantastic. We finished. Let's see. Let's put it back. Color it. Show in browser. So we did this. Fantastic. Thank you. If you like my stuff, pay me, okay? xali.info. Go to xali.info. All the way to the bottom, Patreon or Amazon gift card or PayPal, okay? Pay me $100. If you have a job and like my stuff, okay? Thank you. That's it. Any other questions? Now, Saifu, this Saifu guy, I don't know what you're doing, is a troll.